We're going to discuss linear relations in this video, and we want to really look at the Cartesian coordinate system because that's what the linear relations are going to be graphed on. So you may not recognize the name Cartesian coordinate system, but you probably recognize the picture down here that I've drawn of the x and y axis. Okay, so you probably are used to that, but what we're going to do is we're going to take points first and then equations, and we're going to attempt to graph them. We're going to attempt to put them on this coordinate system. So you have to know a couple things about that coordinate system first. One is you have to know that here at the origin, this is the point 0, 0, all right, where they meet. So that's the point 0, 0. That's the first thing you need to know. And then you need to know that x is the horizontal axis, and it goes, this is the negative x down here, and y is the vertical axis. So we're going to have y and minus y. And again, this is probably review. You've probably seen this before. And then you have to know that when you're plotting a point, a coordinate point, you always put the x first and then the y. So if I'm going to plot 3, 6, assuming that this is a scale of 1, so we're going to go 1, 2, 3, we're always going to start in the x, and then we're going to move to the y. We're going to go 1, 2, 3, 4, 5, 6. So there's 3 and 6. Okay, minus 4 and 0. We'll go 1, 2, 3, 4 in the negative. Minus 4 and 0 is right there. So we'll just identify these by color so you can kind of see where we're plotting each one. 8 and minus 1. We go 1, 2, 3, 4, 5, 6, 7, 8 first in the x, and then down 1 in the y. So there's 8 and minus 1. All right. Minus 5 and 10. Again, we start with the x. So we go minus 1, 2, 3, 4, 5, and then we go up 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're going to have to scroll up just a bit. There's 10. I count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Okay, and then minus 7 and minus 3. We go back. That's minus 5. We already know because we just did that. So minus 6, minus 7. Then we're going to go down 3. So minus 1, minus 2, minus 3. So there's minus 7 and minus 3. Okay, and then I don't know, we're going to have enough colors here, but we'll try 0 and minus 5. We're just going to go down 1, 2, 3, 4, 5. There's 0 and minus 5. That is a very bright yellow. And then minus 10 and minus 10. We'll go back to black. But minus 10 is going to be back here. That's minus 7, minus 8, minus 9, minus 10, and minus 10 is down here. So it's kind of down. You count it out. All right. So that's how you plot points. And essentially, the reason we start with that is because essentially what we're going to do is try to get a table of values from an equation or from a scenario that we're given. And then once we have a set of points, we're just going to plot them. And what we're looking for when we talk about linear relations, what we're looking for is we're looking for, first of all, an independent variable and then a dependent variable. So we're going to look, first of all, for a variable that we get to decide. We have control over. That's the independent variable. All right, it's the variable whose value is not dependent on anything, on any other variable. So generally when we graph situations, it's going to be something like time. Okay, time is an independent variable. But we'll look at each situation to decide which one is it that we get to decide or that we change. That's the independent variable. The dependent variable is the variable that is dependent on the independent variable. Okay, so basically it's a variable that's dependent on our x, and we put that on the y-axis. So the independent variable, we decide what do we do with that. We pick the values for that, and then once we've picked a value for that, then the y value, the dependent variable, is going to be something based on our choice of x. Okay, so, and it's going to be based on an equation or a scenario that we're given. And then what we do is after we've created a few points, so we've created a few x values and y values, then we plot them. We put them on the graph. That's why I reviewed in the first part here just how to graph a point. Okay, how do we graph these points? Because we're going to create a table of values using our independent variable and our dependent variable. And then once we've decided on our table of values, once we have a series of points, we're then going to put them on a graph, and we're going to see if we can connect them with a straight line. If we can, then it's considered to be a linear relation. So that's why we're calling this whole section linear relations. We're going to try to look at a situation, get a table of values, plot the table of values on a graph, and look at the graph and say, is this able to be connected with a line? If it is, then it's a linear relation. If it's not, then it's not a linear relation. Okay, if we can't connect it with a straight line, then we say it's not linear. The key thing about a linear relation is that a change in one variable produces a consistent change in the other variable. So in other words, there's a consistent change. And if you look back in the previous video, you'll see when we looked at tables sometimes and when we looked at equations that we were trying to sort of map out an equation for a situation, we saw that things went up by the same amount. And that's what it means. So in other words, if we're going to change one variable, the other variable is going to change by the same amount. It's a consistent change. And we called it in the previous video slope. Okay, so if we look at this, here's an example. It says the cost of a cab ride is a flat rate of $2 plus an additional cost of 15 cents a kilometer. Graph the cost of the cab ride. So the first thing we have to decide is what is the independent variable and what's the dependent variable. In this case, the dependent variable is the cost. And the reason it's dependent is it's dependent on this. It's a rate per kilometer. So depending on how many kilometers we drive, that's going to determine how much it costs. Okay? So we're going to choose a variable to represent the total cost of the ride, and I'm going to call that C. Okay? And the number of kilometers traveled, I'm going to call that N. And I'm going to say this is my independent variable. Okay? And I know it's small, but it's the independent, and this is the dependent. So what I'm going to do is independent goes in the X, and then the cost is going to go in the Y. So we want to create a table of values. Now, if we don't travel any kilometers, there's a flat rate of $2. So we're going to have, it's going to cost us $2 basically just to get in the cab. If we travel 10 kilometers, okay, then we're going to have an extra $1.50 because it's 15 cents a kilometer times 10 kilometers. Okay, so that's $1.50, and then plus the $2. So that's going to be $3.50 total, right? 3.5. Then I can go up by whatever I want. I'm going to go up by 10. So if I add another 10 kilometers, that's 20. 20 times 0.15 is 3. And then we're going to add 2. And that's going to give us 5. And you'll notice something. If you consistently jump in the X or the independent variable, so if I go up by 10 here and then 10 again, this will jump by the same amount because I'm just multiplying this number, whatever number I'm putting in, by 0.15. Okay, so I notice it goes up by 1.5 here. Then it's jumping by 1.5 again because because I'm multiplying 0.15 by an extra 10, which is 1.5. Okay, so that means this is going to be 650 or 6.5, and this 40 is going to end up being 8. Okay, so there's my table of values. Because n is the independent variable, I can choose whatever I want here. I could have gone up by 1. All right, it doesn't make a whole lot of sense. If you're going for a cab ride, you're probably not going to jump in a cab to go a kilometer. All right, if you are, it's either pouring rain or snowing, or you're just being a little lazy, right? So because you're a kilometer is not very far to walk. So that's why I jumped by 10 kilometers, because now we're talking, okay, 10 or 20 or 30 or 40 kilometers. Now we're talking a pretty significant distance, right? 42 kilometers is a marathon. So we're probably not going to walk 40 kilometers if we can pay $8 and get a ride. So that's why I chose to go up by 10. You could have chosen to go up by 5. You could have chosen to go up by 100. Doesn't matter. That's your choice. You'll notice, though, because I chose those values, then the cost, the dependent variable, was determined by the choice of n. Okay? So that's what we're talking about when we're talking about the independent and dependent. We're saying the independent variable, you get to choose what you go in the cab. Your choice is how far you want to go. But once you've made that choice, the cost is dependent on that choice. So the cost is determined based on the value of the independent variable. So that if I went 50 kilometers, then it would be another $1.50 be $9.50. I don't get to decide what the cost is. I just get to decide how long I stay in the cab. Okay. Now, the next part of this is actually to graph this. Okay. So when you want to graph it, what you need to do is you need to pick a scale. What am I going to go up by? All right. So the first thing you need to do is draw a set of axes. So I'm going to do that. So I'm going to call this axis down here. This is going to be my x-axis, in our case at 10, right? And then on the y-axis, we're going to put the cost. Okay, and the cost is going to be in dollars. And then you have to decide. Sorry, it doesn't look like a dollar sign now. It's a big mess. Let me fix that. Now you have to decide what's your scale going to be. What are you going to go up by? All right. So I'm jumping by 10, my number of kilometers. I'm going to go 10, 20, 30, 40. That's going to be pretty small, right? It's going to be hard to sort of see. So I'm actually going to go up by 5. So anyway, that's 10. This is 20. Okay, and then 25, 30, and then 35, and then 40, and then 45 and 50, and it would keep going. I don't need to label all of them. For my cost, it's going up by $1.50 every 10, right? But it starts at 2, so I'm just going to go up by 1. So there's 1, there's 2, and then 3, 4, 5, there's 5, 6, 7, there's 8, and then 9, 10, 11, 12, let's say. Okay, and again, you don't have to label all of them as long as you keep a consistent scale. So then what we're going to do is we're going to plot the point. So at 0, it's at 2. So I'm going to plot that point, and I'll plot them in blue just so you can see them a little better over top of the red. So there's 0 and 2. Then I'm going to plot 10 and 3.5. So this is 3 and that's 4. So 10 and 3.5 is right about here. Then at 20, I'm at 5. I'm right here. Then at 30, I'm at 6.5. So right about here for that one. And then at 40, I'm at 8. So I'm going to go 8 is here and 40 is right there. So what I'm going to do is I notice that those are linear. They're in a straight line. So I'm actually going to draw a line through them. Okay. Now it's not perfect just yet, but I'm going to try to make it a little more perfect. Okay. I can bend the line just a little bit to make sure that it goes through exactly all the points. There we go. Okay. And then I can extend that line and I can use it to predict things. Okay. So that's my line. So now I look at my line and it says the determine the cost of a that's 12 kilometers long. So 12 is going to be, this is 15, remember, right? So 10, 11, 12, 13, 14. So 12 is going to be kind of here-ish. Okay, and from our graph, that's going to look like about, I'm going to say 3.75. So that's just my guess from the graph. Okay, now it's not exact, or it might be. It depends on how well you drew the graph and how straight these lines are and how good your scale is and all of that. If you wanted to determine the cost at 12, not from the graph, you could say it's $2 plus 12 times 0.15. Okay, so if you multiply that out, you go 12 times 0.15 and then add 2, it actually comes out to 3.8. So my guess from my graph, and I'm saying guess just because my scale is not perfect, is pretty close to the exact value. It rounds to the same amount. But that's how you would use your graph. Now down here it says, how far could you travel if you had $24 in your wallet? So you notice my graph doesn't actually go to 24. Okay, so I can't use my graph to solve it. But I can say if the cost is $24, okay, then that cost is made up of, I'm going to subtract the $2 that it starts with, okay, so it's going to be $22 that I travel in terms of kilometers, and all I'm going to do is divide that by $0.15 per kilometer, okay, and I'm going to see what that gives me. So if it cost me $22, how many kilometers could I travel? And it's 146.6 repeating. Okay. So again, if we wanted to write an equation, and you would have done this a little bit in the previous video, cost would be 0.15 times the number of kilometers, okay, and then plus $2. So if we want to do it algebraically, just to sort of show you, I did this sort of freehand a little bit. I would say this is 24, and that equals 0.15 n plus 2. So then I would subtract 2 from both sides. That's this part, okay, of my calculation. So I get 22 is 0.15 n. And then to solve for n, I divide by 0.15, which is this part of my calculation, okay? And so therefore I can say n is 146.6 repeating. You can go almost 147 kilometers. Okay, if we look at another example, this example actually gives us the relation. It says, here's the equation, 3x minus 2. And it says, create a table of values for the relation for values of x from -3 to 3. So what we're going to do, I'm going to go -3 to 3. So -3, -2, -1. And then 0, and then 1, 2, and 3. All right. And we have y equals 3x minus 2 as our equation, right? So what we're going to do is we're going to take each of these numbers, multiply it by 3, and then subtract 2. So I'll just show you for the first one here. You're going to go 3 times -3 and then -2. So that gives you -9 minus 2, which is -11. For the next one, you go 3 times -2 minus 2. So that's -6 minus 2, and that gives you -8. Okay, so actually I'll just write it right there. If you do -1, you'd go 3 times -1 minus 2. That gives you -5. Okay, and you can notice now, I think, that the pattern is you're going up by 3, which is this number here. So this is just going to be -2. I'm just going to add 3. It's going to be 1. And if I add 3, that's 4. And if I add 3, that's 7. Okay, and then it says graph the relation. So now we're going to graph this. So -3 and -11, what you notice is you have to start making a scale. So 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. So -11 is actually down here, all right, if I go up by 1. And -3 is right here. So -3 and -11 we're going to say is right there. Then -2 and -8 is right here. Because that's -10, -9, -8. Then at -1, I'm at -5. Is right here. Okay, 1, 2, 3, 4, 5. At 0, I'm at -2, which is right here. Then at 1, I'm at 1. At 2, I'm at 1, 2, 3, and 4. Okay, and then at 3, I'm at 7. And then what you notice is can I actually create a line that will go through all these points? And my eye sort of tells me yes, you can, and it looks like that. All right, and it does actually match all those points. It is linear. So it says, describe any patterns that you see in the graph, and how do you see these patterns that relate to the table of values? What you want to notice is the jump here, that the points are jumping by 3, okay? That's what's going on because of that 3 there. So it's called the slope, but that's the pattern. And as x goes up by 1, you'll notice y goes up by 3 each time, right? So I go over 1, run 1, and I rise 3. I run 1 and I rise 3. In other words, I go over 1, add 1, and then I add 3 to the y each time. 1 and 3, then 1 and 3, 1 and then 3, 1 and then 3. Okay, and it would keep going. So 1 and then 3. You'll notice there's another point up here. I haven't got that in my table, but at 4, we can see it would be at 10. Okay, and then the question says, is the relation linear? And the answer is yes. And the reason it's linear is A, you can look at the graph and determine that it's linear because you can put a line through all the points. Or you can look at the fact that it's jumping by the same amount. And if your table does that, then it's also linear. Okay. So this question says your turn. So I'm going to let you take your turn, okay, and try that question. It's given that the equation, complete the table of values and then see if it's linear, okay? What I'd like you to do is just, I'm going to fill in the answer, okay? And I want you to pause the video now and do it yourself first, okay? And then once you're done that, now you can see the answer. So hopefully you pause the video and tried it, and then you can see the answer. So this is minus 9, then minus 5, and then 0 is going to be minus 1, and then 3 is going to be 5, and then this is going to be 9. Okay? So what you'll notice is as this jumps by 2, this is going up by 2 each time. Okay? This is jumping by 4 each time. Then I go to graph it. So 1, 2, 3, 4, here's minus 4, and I'm at minus 9. So if I count down, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's minus 9. Then I go to minus 2, and I'm at minus 5. So if this is minus 2 here, I go down 1, 2, 3, 4, 5. Then at 0, I'm at minus 1. So that's right there. Okay, I'm just going to label that as minus 1. This is minus 5. And this as minus 9, just so we know where we're at in terms of our scale. You always should put some form of a scale on your axis. And then this actually jumped by 3 here. Okay. So you'll notice that when I jump by 3 on that one, this jumped by 6. Okay. But it will still be in the pattern. So 1, 2, 3, I go up 1. If that's 3, then I go up 1, 2, 3, 4, 5. That's right here. Okay. And then finally at 5, so here's 5, I'm up at 9. So 5, 6, 7, 8, 9. There's 9. And you'll notice that even though the jumps are a little bit inconsistent in the x values, which makes the jumps a little bit inconsistent in the y values, if I try to draw a line through here, I am able to do that. Okay? It's not perfect just yet, but I can make it so. All right, so there you go. Goes through all the points. So the relation is linear. So hopefully that's what you got. It's a good idea, just on that topic of an inconsistent jump here in the x, it's a good idea to jump by the same amount. So you'll see most tables that you're given, and if you're going to create a table, my suggestion is to jump by the same amount in the x. Go up by 2 every time, go up by 3 every time, go up by 1. It doesn't really matter what you go up by because it will depend on the context of the question. But it is important you jump by the same amount because then you can notice patterns in the y. All right. So that's your turn. And then here's another one. And I want you to notice again, this table doesn't jump consistently in the x. You'll notice hopefully that because if you look here, this jumps by 2, right? I add 2, and then it keeps adding 1 after that. So it adds 1 there, and then adds 1 there. So if we look at this, same idea, but if I put in minus 3, I'm going to get minus 4, minus 3, and then minus 2. That gives me 12. Okay, minus 4 times minus 3 is 12. Minus 2, so that gives me 10 in there. Okay, if I switch colors just so you can see what I'm doing and put in minus 1, I'm going to have minus 4 times minus 1, minus 2. Minus 4 times minus 1 is 4, minus 2, so that gives me 2. Okay, then if I plug in 0, and I'll do that down here, 4 times 0 minus 2, or minus 4 times 0 minus 2 is minus 2. So this becomes minus 2. And then if I plug in 1, I get minus 4 times 1 minus 2. That actually gives me minus 6. Okay, so that's minus 6. And then finally, go back to my shocking yellow color here for a minute. Minus 4, you don't even know if you can see that. Woo, that is bright. So you get minus 10. Okay, and I'm sorry about the brightness, but then you just graph these. And I'm not going to graph all of this because I don't think you need to sit here and watch me do that. But minus 3 and 10 is here. Minus 1 and 2 is right here. 0 and minus 2 is right here. And just graphing those 3 points, you'll notice I can draw a line through those. Okay, it's a very steep line. So I'll just move it over here. And then I I just got to grab it and sort of fix the end of it so that it goes through all the points, okay? And what you'll notice is if I extend this down, that it actually goes through 1 and -6 right there, and it goes through 2 and -10 right there. Okay, and so that it is linear because it can be connected by a line. So again, here's another your turn. This time I'm going to let you do that on your own. You can get your answer from your teacher. And then after that, you'll see there's a bunch of textbook practice questions and the answers. Okay, and I'll leave those for you to try through the posted notes on Microsoft Teams.